Hello everyone, my name is Chengkai Xia, a PhD student in School of Chemical Engineering in SKKU, and one of the PEC Great Challengers in 2021. My supervisor is Professor Junggu Kim. Now let me introduce my recent work for about crystalline nickel complex decorated tungsten oxide photoanode for efficient water splitting. As we all know, hydrogen is an ideal energy carrier because of its environment-friendly and high power densities. So how can we get the hydrogen fuels? Usually, we based on the protocols of water splitting. Recently, photoelectrochemical water splitting, as we said of PEC water splitting, is becoming an eco-friendly protocols for hydrogen productions. In order to generate the hydrogen fuels in a low price, it has some requirements for the PEC photoanode. Usually, it should have a suitable band gap, low resistance, high stability, and one more important issue is earth abundant. For these reasons, tungsten oxide becoming unwelcomed materials for that. However, in order to get better charge transfers, we try to reduce in the solid and liquid interface resistance. In order to get this issue, we try to create some carbon-based materials on the surface for that. Now we choose crystalline. In our works, we try to transfer the crystalline into crystalline and some metal complex. During our experiment, we choose nickel as the challengers. Based on the followed protocols, we decorated crystalline and nickel complex on the surface of tungsten oxide photoanode. As the characterization result shows, we successfully decorated the crystalline nickel complex on the surface of tungsten oxide nanoparticles. Here we can see that a very thin layer is decorated on the surface of tungsten oxide nanoparticles, and our EDS mapping is also shown that on the surface of tungsten on the layer part here, the carbon and nickel's content is significantly higher than other places in our layer part. So, as we checked in our PEC performance data, it can be shown that comparing to the bare tungsten oxide, our decorated samples shows a very significant increase for the water splitting performance at 1.23 volt with RHE. And our other characteristic also shows that the charge transfer and transport efficiency is increasing after doping the crystalline nickel complex. And it can be and next plot and other characterization like UV-vis also shows that. Moreover, we also tried it in KPI electrolyte at pH about 7. It shows that our decorated layer can also provide a better stability and under different conditions to acid conditions. It means that it can provide a better stability in different environmental conditions for our tungsten oxide materials. This is our recent progress. Thank you, everyone.